Hello, today we're going to start talking about sequences. So sequences are just a list of numbers, and we are going to focus on two main kinds, arithmetic sequences and geometric sequences. In order for a sequence to be arithmetic, we need to add the same amount every time. This might also look like subtraction. Subtraction is just adding a negative. Geometric sequences, we multiply by the same amount every time. It might look like division, because division is the same as multiplying by a fraction. So we're going to be looking at these patterns of numbers, list patterns of numbers today. We're going to say if they are an arithmetic sequence, and if it's arithmetic, we're going to say what the common difference is, what we're adding each time. If it's a geometric sequence, and if it's geometric, we're going to say what the common ratio is, what we multiply by each time. Or if it's neither of those two things. If we're not always adding the same amount or multiplying by the same amount, it's a neither. So let's take a look. I'm actually going to work backwards. I'm going to start down here. So my list or sequence of numbers is 16, 25, 34, 43, 52. There's no nice number that I multiply by to get from 16 to 25, so it's probably not geometric. What do I need to add to 16 to get to 25? To get from 16 to 25, I add 9. And then if you look at the next few numbers, if you add, we're adding 9 every time to get to the next number in the sequence. So since we're adding the same amount every time, this one is an arithmetic sequence. And our common difference, which I'm going to abbreviate as D, is 9. Looking at this one, we have negative 16, 8, negative 4, 2, negative 1. If we're thinking what we would add, so to get from negative 16 to 8, I would add 24. But if I add 24, I don't get negative 4. So that doesn't work. So it's not arithmetic. You might think, okay, to get from negative 16 to 8, I divided by negative 2. But dividing by negative 2 is the same as multiplying by negative 1/2. To get from 8 to negative 4, I would divide by negative 2, which is the same as multiplying by negative 1/2. And we see that that pattern is consistent throughout. So since we are multiplying by that same fraction every time to get from one number to the next, this one is geometric. And since it's geometric, the common ratio is what we multiply by each time, which is negative 1/2. I'm going to continue working backwards. So we have 10, 12, 15, 19, 24. To get from 10 to 12, I add 2. To get from 12 to 15, I add 3. So it's not arithmetic because I'm already not adding the same amount every time. Multiplying by wise, I would have to multiply by some sort of strange decimal to get from 10 to 12. And it's not going to be that same decimal amount consistently for these. So since I'm not adding the same amount every time, I'm not multiplying by the same amount every time, this one is neither. There's probably a pattern here, but it's not specifically arithmetic or geometric, so we're going to call it neither. Next up, to get from 11 to 17, I add 6. 17 to 23, I add 6. And we can see that that pattern continues consistently. So since I'm adding the same amount every time, this one is arithmetic. And the common difference is 6. Next up, to get from negative 1 to negative 3 over 4, I would add 1/4. It's not the same amount to get from negative 3/4 to negative 3/5. So this one's not arithmetic. To get from negative 1 to 3 over 4, I would multiply by 3 over 4. But if I do negative 3 over 4 times 3 over 4, I do not get negative 3 over 5. So I'm not adding the same amount every time. I'm not multiplying by the same amount every time. Since we're not adding the same amount or multiplying by the same amount, this one is also a neither. All right, last one we're going to look at. It doesn't look like we're adding the same amount every time. It does look like there's a pattern in the bottom numbers of our fractions, which means we're multiplying by some sort of fractional amount. The way you can check this is you can work backwards. If I do this number divided by this number, it'll help tell me what my fraction is. So I have I have an extra number here that I don't need to have. So let's kind of reset here. The sequence I'm dealing with here is 2, 1/2, 1/8, 1/32, 1/128. I had accidentally written an extra number in there. So same process applies though. It looks like we have a pattern going on here. You can try this one of two different ways. You can either check by work dividing. If I do 1/2 divided by 2, I get 1/4. And that's going to be consistent if I work backwards. The other way you can look at this is easier with the fractions. How do I get from one fraction to the next? To get from 2 to 8, I multiply by 4. To get from 1 to 1, I multiply by 1. So the other way you can think of this is multiplying by 1/4. So whatever works for your brain. It is consistently that we are multiplying by 1/4 every time to get from one number to the next. So since I'm multiplying by the same amount every time, this one is geometric. And our common ratio is 1/4. Feel free to use a calculator to help you figure things out, especially with geometric. When it's geometric, you're always welcome to work backwards by dividing one term divided by the term before it to help you figure out what that fraction is. We could have done that back here too. 8 divided by -16 is -1/2. So that is it for sequences. We're just seeing if they're arithmetic or geometric, telling what the difference is if it's arithmetic, what you added every time, what the ratio is if it's geometric, what you multiply by every time, and if we're not using the same amount every time to get from one to the next, it's neither. Have a great day.